Good morning, Section F. My name is Afshan Chandani, and this is the final report for Team Incendio, which consists of myself, Kyle Mulholland, and Jesus Pacheco. In this presentation, we're going to go over our problem understanding, our design concepts, our evaluation method, our final design, our preliminary testing results, our competition results, and the future design improvements that came from them. In order to start understanding the problem, we created a house of quality. The most important customer requirements from our house of quality were fitting in the box to prevent disqualification, extending to the center to get to scoring opportunities, retracting from the center to double our points, and being durable for multiple uses. These informed engineering requirements, the most important of which were decreasing the volume of the robot to meet the size requirement, increasing the length of extension to get to the points, and reducing the number of squash balls collected in order to limit the negative points gained in the rounds. These requirements were later specified in a specification sheet with values such as the volume of the robot having a maximum of 5,184 cubic inches, our target length of extension to be 36 inches, our total price to be a maximum of $100, and our time to set up to be a maximum of 3 minutes. The main function of the robot, which was to score points, was then broken down into 7 subfunctions, which were extending to the center, retracting from the center, sensing the wall drop, placing the tennis ball, moving the dog bone, collecting gems, and not collecting squash balls. This function tree was later used to generate ideas, which was put into this morphological chart. This is an image of the first design concept we created. Morphological chart selections for concept 1 were extending to the center with gravity, sensing the wall drop with an IR sensor, moving the dog bone using a passive hook, avoiding squash balls with a filtration system, retracting using a winch, placing the tennis ball with a motorized arm, and collecting the gems with a passive redirection mechanism. The advantages of this design were reliable squash ball avoidance as shown in tests, being easier to box since there were no sensors sticking out of the front, reliably securing the dog bone, and sensing the wall drop. Disadvantages were that it was harder to retract due to only a single motor pulling, and it was slower to extend because it relies on the lubrication of the drawer slides. This is an image of design concept 2. The morph chart selections for concept 2 were extending via pneumatics, sensing the wall drop with an IR sensor, moving the dog bone with a pneumatic push, avoiding squash balls using an intake filter, retracting using a counterweight, placing the tennis ball with a ramp, and collecting the gems with a passive redirection mechanism. The advantages of this design are that it senses the wall drop, it's fast to extend with the pneumatics, and it pushes the bone into an enemy area. The disadvantages were that it did not have very reliable mechanisms for retraction, squash ball avoidance, and dog bone movement. This is an image of design concept 3. The morphological chart selections for concept 3 were extending with gravity, sensing the wall with a limit switch, moving the bone with the passive hook, avoiding squash balls using a roller, retracting using a pneumatic pull, placing tennis ball with a motorized arm, and collecting the gems with the same roller that we push away the squash balls. The advantages are that this design senses the wall drop, it's easier to set up since it requires no mouse traps, and it reliably secures the dog bone every time. The disadvantages are that it would be very hard to box due to the sensor sticking out to the front. The retraction system was not proven to be reliable, and it is slower to extend because it relies on the lubrication of the drawer slides. We put all of these designs into an evaluation matrix. In the end, the final design was design concept 1, and this was chosen mainly because it was easier to box and also had key advantages in collecting the gems and avoiding squash balls, as well as being able to sense the wall drop and place the tennis ball consistently. This is an animation of design concept 1. And here it is in a competitive setting. Here it is placing the tennis ball into the center. So this is the fully constructed final design. And also we have our bill of materials here, and we ended up with a total cost of $58.10 for the entire machine, not including fasteners. This is a video of our extension subsystem in action. As you can see, the pneumatic pin pulls up and releases the drawer slides. Here's the dog bone system. As the mechanism retracts, the hook slides under the bone and pulls it safely into our starting zone. Here's the gem and squash ball system. As you can see, the plastic pulls up the balls and redirects them into our filter where the balls roll out and the gems get collected. This is the tennis ball system. As the ball drops, the IR sensor senses it and flips forward the arm on the motor to place the tennis ball. And finally, here is the retraction system. Once the time has been called, the motor turns the pulley, which pulls a string, pulling the entire system into base. Here is a full systems test in which everything worked. While we were testing this system, we found that almost every system had a success rate of 90% or above, with extension and retraction always working. The one system that was not having consistent test results was placing the tennis ball, which only had a 75% success rate due to other teams getting to the center first. As you can see in this test scenario, every single action that our robot needed to complete was completed successfully and within time. So in the qualifying competition, we scored pretty well. Our best score was 50, which was this round shown here, even though our dog bone system did not end up functioning in this round. So in the final competition, our first round resulted in us placing first, our second round resulting in a DQ due to a pulled power wire, and our third round resulting in a fourth place finish. So we only made it to the third round of competition. The video playing is our last round. As you can see, there were some issues in the competition that we weren't seeing during our testing periods. One of the things that you might have noticed was the dog bone mechanism getting stuck. This had never happened in any of our tests, so we were kind of confused as to why that was, but we ultimately determined that the newly painted tracks resulted in more friction, which caused the dog bone hook not to slide properly as it was intended. We also had some issues with squash balls pushing up our wedge, which again didn't happen in any of our preliminary tests. So we again assumed that to be slight differences in the competition tracks based on what we saw during our rounds. Our overall results were we placed 12th place out of 59 in the design review and 38th place out of 59 in the competition. Our future design improvements would be to increase the height of the dog bone hook in order to account for the increased friction with the track, to create an angle limiter for our filtration wedge in order to completely stop the squash ball problem, and also to create a precise guide to assist in placement, since that was the only thing impeding the accuracy of our tennis ball placer. Thank you for listening to this presentation. Do you have any questions?